Good afternoon all. So we are going to start our today's session. So wait for 2-3 minutes, then we will start. So let's start the session. This is week 2 sensor and actuator course problem solving session. So this is about me. I'm ARPITA Biswas. Currently I'm pursuing PhD in electrical engineering department from IIT Jodhpur, and this is my educational background that I did my MTech from IIT Jabalpur in micro nanoelectronics, and I did my BTech in electronics and communication engineering from WBOT. And this class session is time is Tuesday 7 to 9 p.m. So if you have any query over anything else, then you can discuss with me, and we are going to solve some of the question here. So let's start. So this is the question number 1, that the Excel breath analysis for diabetes diagnosis is a. The first option is liquid phase VOC detection, that is minimally invasive procedure. Second option is the solid phase VOC detection, that is invasive procedure. And the third option is the gas phase VOC detection, that is minimally invasive procedure. And the fourth option is the gas phase VOC detection, that is non-invasive procedure. So please unmute yourself and try to give this answer. Am I audible? Hello?
Yes, ma'am.
Okay. Please try to solve the question. Ritesh Kumar? Okay, Preeta Yogi, option D. Anyone else?
Ma'am, option D.
Okay. Anyone else? Can anyone tell what is minimally invasive procedure, or any example of the minimally invasive procedure, or what is invasive or what is non-invasive process? Anyone can explain? Please unmute yourself and try to explain. Sashi Bhushan?
Hello.
Yes.
Yes, ma'am. Invasive means we are inserting some tool inside the body, or non-invasive means we are taking the measurement outside the body. I think I understand what.
Yes, and what is minimally? Can you give an example of the minimally invasive process or procedure?
Minimum, like the sugar detection method, where we taking one drop of blood for the measurement.
Yes, you are right. So the answer is option D, the gas phase VOC detection, that is non-invasive procedure. Preetham, can you explain why option D is the right answer? Because here
because in this we are not taking any material from the body, we are just detecting the gaseous phase of the material that we want to measure.
Yes, yes, you are right. Very good. So we are moving towards question number 2. So the question number 2 is, which among the following is a minimally invasive diagnostic procedure? Heart transplantation, surgery, neurosurgery. Third option is the disease detection using breath analysis, and the third option is the glucometer based disease detection. So please unmute yourself and try to give the answer.
Ma'am, option D, ma'am.
I think it is C, ma'am.
Sorry, I did not hear you.
I think it is C, breath analysis.
Option C.
Can you explain why breath analysis is minimally invasive? Please unmute yourself and try to give the explanation. Why minimally invasive is breath analysis only? And what is the reason? Please explain. Hitesh Khanna. Sagar V.
Option D is the correct answer, ma'am.
Why option D is the correct answer? No, why not C?
Ma'am, C is non-invasive, ma'am. D is minimal invasive. We are using glucometer to detect the diabetic disease, ma'am.
Okay.
That's
Anyone?
why option D, ma'am.
Yes. And anyone else? Those who are telling option C is the correct answer, can you please explain why you are going for this option? Please try to explain.
Because we are just minimally inventing some device to measure the breath.
But it is outside of the body and only we are detecting the breath, no? So why it is minimally, why it is not invasive? Now my question is it.
Okay, I think you're right.
Anyone else? Sashi Bhushan?
Yes, madam. What I thought was it does not require any body part to be cut.
Yes.
So I think it is not at all invasive. So there is no question of minimal, I think.
So what is the right option?
I think I agree with D.
Okay. Glucometer.
Yes, because it requires only
Only
small.
one drop of.
Yes, only.
Okay. And can you tell me what is happening for the non-invasive method?
I think with regard to option C, it does not require any sectioning.
Yes. And what is happening for invasive?
So we need to cut the body part for the
Okay.
blood to be examined
So
or for any
can you
other.
explain the right option? Sorry, for heart transplantation surgery. For in this case, what is happening? Invasive, non-invasive, or the minimally invasive method? It is
Which one, madam? Option 1.
heart transplantation surgery is a which procedure?
It is major invasive. It involves major sectioning, no, madam.
Okay, so it is a invasive or non-invasive process.
Yeah, it is invasive only.
Okay, and for the neurosurgery?
Neurosurgery, I am not much perfect about that, madam. I could not get that neurosurgery, how the operation will be taking place.
Okay. And for the breath analysis?
Breath analysis, it is completely external. They examine the breath, that is the air that we exhale, that will be analyzed. It does not require any body part to be section.
Yes. Okay. Anyone else? What is the right answer?
I think option one is heart transplantation surgery
Sorry, I did not get you.
because
What is
it
the
is
right
a
answer?
aggressive technique. I think one heart transplantation surgery is the most invasive diagnostic procedure.
Okay. So, which option here is the right answer? Option A, B, C, or D? Actually, your voice is not clear.
D is the correct answer because only we need a very minimal method of inventing any device into the body.
Okay. Hitesh Khanna? Hitesh?
Yes, ma'am.
Yes, what is the
Am
right
I
answer?
audible, ma'am?
Yes, yes.
Ma'am, option 1 is correct, ma'am, I think. Because heart transplant surgery is an invasive technique.
Sorry, I did not get you. Your voice is not clear. How heat transplantation surgery is a minimally invasive? Can you please explain? Anyone else?
Not that of many several things.
See, for the heart transplantation, okay, heart surgery is maximum invasive. Yes, this is the Pritam Yogi. Okay. Yes, for heart surgery we need the heart surgery is an invasive procedure because we have to put some devices into this body. But for the glucometer based disease detection, we are used minimally invasive diagnostic procedure because here we only need one drop of blood. On the device we put it and we measure the glucose level. So the right answer is option D, the glucometer based disease detection. So we are moving toward question number 3. So the question is, the mask having dark feature and transparent background is dark field mask, bright field mask or gray mask or black and white mask both. So please unmute yourself and try to give the answer. Okay, Pritam. Anyone else? Okay, you can unmute yourself and you can directly say the answer now. A.R. Venkataraman. Please unmute yourself and try to give the answer.
Black and white mask.
Why black and white mask? Can you explain? Can you tell me
Because
what is dark field mask and what is bright field mask?
it should be observing that heat. So due to that only, I am saying that it should be having a dark feature and a transparent
Yes.
background for
What
that
what
purpose. There is
what feature we want? This is a black feature. Sorry, dark
okay.
feature, and
Okay.
and the background is transparent. Transparent means the UV light, where the source light can easily pass through it. So maximum space of the um, uh, mask is transparent. So in that, the type of mask, what type of mask?
Bright field.
Okay. Anyone else? Please unmute yourself and try to give the answer. Shashi Bhushan? Sagar V? Ankur? Please unmute yourself and try to give the answer.
Yeah, dope, ma'am. Yeah.
Sorry, what is the right answer? Your voice is not clear, Hitesh. You can also write here, no? Anyone else? Prashant? Prashant? Shashi Bhushan?
Yes, I think it is one dark field because as I said, the dark features, having dark features and transparent background.
Why it is dark field? Why it is not bright field mask? Can you explain?
I see. As I understood from the question, it is that the background is dark. It's a transparent background.
No. The
And,
background is not dark. Actually, the feature what we want, this is dark, and the background is transparent. Okay.
Okay.
And from the transparent portion, the light can goes.
Okay.
So, what type of mask it is?
Yeah. Bright field or the second one?
Okay, bright field mask.
Yes.
Okay. Anyone else?
Ma'am, it's a bright field mask because in center part it is dark, so it is dark features, and covering is transparent, so both will cover no, ma'am.
Okay, good. Anyone else?
Ma'am, I have a doubt, ma'am. So what is the difference between mask and photoresistor, ma'am? So what is the purpose of fitting mask onto the photoresistor?
Actually, we are not
Make
fitting the
it-
mask onto the fridges. Only
Ma'am, I'm
contact.
audible?
Only contact type photolithography. We contact with the mask with the photoresist. Okay. Let's see. What is the need of the photoresist? What we all want from this lithography? It is a part of the lithography. When the photoresist is coated with the desired pattern or with the device like a silicon dioxide, we want to get some pattern. Then what we do? At first we coated with this silicon dioxide with the photoresist, then the pattern transforming. The pattern is in the mask. Then we are here it is the light, and then this is the mask, whatever dark field or bright field. Then here is a photoresist. Okay, so pattern is in the mask. When light is goes to the to this mask, then the pattern is transforming from the mask to this photoresist. Then we dissolve, then we UV exposed or do the lithography process, and then we dissolve into a solution. Then the desired pattern, whatever it is the mask and the characteristic of it, it is like it is dark field or the bright field, and what is the type of the photoresist, like it is positive photoresist or the negative photoresist, so it also depends on it. Then the pattern transforming from the mask to the photoresist, then we do some process, then we get the pattern transforming from the photoresist to the desired device like SiO2 it is transforming. Now you can understand the difference between the mask and the photoresist.
So, ma'am, what I can get is it just to protect the photoresist, ma'am? Mask. The purpose of mask is to protect the photoresist. Am I correct, ma'am?
This is not the sorry, can you question again?
So
What
the
is the
purpose of
purpose
mask
of the
is to
photoresist?
protect
What
just
is the
the
need of this
photoresist.
photoresist, like?
No, ma'am. So what is the purpose of mask to fit onto the photoresist? That is my question, ma'am.
If you want to contact photolithography, then there is a contact between the mask and see there is a three type of photolithography: contact printing and proximity, and also the projection type of. So what type of process you want to use, that depends on it, and you are transforming the pattern from mask to the photoresist. Then after dissolving or the there is some process, so using this process you can get the pattern transfer from the photoresist to the desired pattern, desired device. Because let's see, if we are want to deposit if we are in the device, at first we deposit some silicon dioxide, Then in silicon dioxide or polysilicon, we want to make a IDE pattern like or some heater. So what way the heater pattern, how we will generate on or how we will make in our device. In polysilicon, how we get this device structure, or the it is like an example how you get this ID pattern or something else. So at first what we have done, we take some, if you go for the photolithography process, at first we take take a mask, what is the type, bright field or dark field, and we coated the wafer like in the after the SiO2 we have deposited the, or sorry, we have coated with the photoresist. And you can take for in your desire, you can take positive or the negative photoresist. Then you are UV exposed, it means light goes from here, the mask, to the photoresist, the device which is coated with the photoresist. So the mask pattern, there is a pattern in this mask, so this pattern is transforming into up to above this photoresist, and there is some process like dissolve, development or etching process like this pattern is transforming from the mask to the photoresist, and after this photolithography process, this pattern of photoresist, it is transforming to the device or the silicon dioxide. So this, by this process we can make the ID pattern or something else we are desire, then we can make this. Yes, Pritam Yogi, you are right. Mask is a glass or mask is a glass plate that used to pattern on the wafer. Only the it is useful to transform the pattern on from the mask to the positive to the photoresist. So anyone else, what is the right answer? Hitesh, can you tell me what is the right answer here, and can you please explain? Hitesh?
Ma'am?
What is the right answer?
Option B is correct, ma'am, because in the middle we have a dark color, ma'am. In the background there is a bright color, ma'am. So when UV is exposed, transparent background will be exposed to UV light, ma'am.
Can you tell me what is the actual definition of the dark field mask? Because can you tell me what is the difference between the dark field mask and the bright field mask? Because also for a bright field and dark field, both cases, the dark pattern and also the transparent pattern is here. So if you are telling like this, that for the here also dark feature and the transparent background is present, so that's why it is black and white. So can you tell me what is the difference between these dark field features and the dark field mask and the bright field mask? Your answer can be right or maybe it wrong, but at first at least you can try, na? Please unmute yourself and try to give the answer.
To use
Your voice is not clear. Pritam, can you unmute yourself and can you explain it?
Yes, dark field, if the dark field, the structures are transparent and the rest area behind the structure, that is, I think, coated with some dark material like metal, chrome and any other else.
Okay. And what is the basic difference between the dark field mask and what is the basic difference between with this bright field mask?
They are opposite. In the bright field, the structures are dark. The light is not passing through the structures that is patterned on the mask. And in the dark field, the field is dark and the structure, suppose we want to pattern a square, so light will pass through that square, that is a dark field. And in the bright field the structure is dark, so suppose our same square pattern we want to on wafer, so in the dark field the light will pass through the the dark field, only the structure, the square one, that is transparent.
Okay. So what is the right answer here?
Bright field mask.
Okay, good. So just a minute. So we are moving towards the question number 4. So piezoelectric and piezoresistive are two types of sensor that are commonly fabricated using the technique in microfabrication. What is the difference between these two types of sensor? The first option is there is no difference, both are different name of the same phenomenon. And the second option is piezoelectric sensor accumulate charge in response to mechanical force, while piezoresistive sensor cause change in resistance in response to mechanical force. And the third option is the piezoelectric sensor are easier to interference with the data acquisition system than piezoresistive. And the fourth option is the none of the above. So please unmute yourself and try to give the answer.
Ma'am, I think option B is correct, ma'am.
Okay, can you please explain?
Piezoelectric converts the mechanical. Ma'am, piezoelectric sensors converts
Mechanical. Hitesh, your voice is not clear. You can write. Anyone else?
Ma'am, it converts
It
mechanical
converts
force into voltage, ma'am. Piezoelectric sensor. And
mechanical
piezoresistive
to
converts mechanical force into resistance. Force into voltage, ma'am. Piezoelectric sensor.
okay. And for piezoresistive?
It converts mechanical force into resistance. Change will have change in length.
Okay. Anyone else?
So option 2 is correct, ma'am.
Okay, okay. Anyone else?
Yes, ma'am. I also think option 2 is correct.
Okay. Can you explain?
Ma'am, piezoelectric, these are sensors that when there's mechanical force, there's a change in electricity, like the voltage. And whereas piezoresistive, when there's a mechanical energy applied, there's change in the resistance. So the second point states that. So.
Okay. Anyone else? Sagar bhi? Vishnu? Vishnu?
Same answer.
Okay. Why? Ankur? Ankur? A.R. Venkataraman? Preetham, please unmute yourself.
Hello.
Yes.
Hello, yes, ma'am.
What is the right answer?
According to answer is B, but my question is piezoelectrics are generating some voltage when the force is applied, and in the piezoelectric, a piezoresistive, the resistance of the that sensor is changed. So in piezoresistive, we need some supply to provide that circuit. So we can measure that change in the resistance, but in piezoelectric, we require any voltage or not, I don't know, but it generates some voltage. So I think
Let's
the
see.
external supply is
For
not needed.
for both cases, we are giving some input and then we are getting some output in the form of voltage, which is generate some charge. So we are getting this electric charge into the form of voltage. And what is happening here, when we are putting some force on as an input of the device, then we are getting the output in the change of the resistance.
Okay, so in piezoelectric also we need to provide some supply to the piezoelectric sensor.
In the both cases also you have to give the input, na?
No, input is a force that we are measuring force in piezoelectric may also. And piezoresistive may also be giving force as an input. Like in that the resistance is changing, so that resistance change we have to measure in the form of voltage. But
No,
in
here
the
you can
piezoelectric,
see. Yeah, for the generally in the for the piezoelectric sensor, they are measuring the output in the form of voltage, and for the piezoresistive, they are measuring the resistance.
yes, so in piezoelectric it's generating voltage, so we have to measure that voltage, not provide the any other voltage source to the piezoelectric sensor. That I am understanding. So it's an active kind of transducer, that is no need of any power supply.
Okay, so you are telling that for both cases or for the piezoelectric there is no need of the power
Only
supply.
in piezoelectric, I think no need of power supply. I have a doubt actually. I mean, in a transducer level, we studied that this piezoelectric not need require any power source. But in resistive transducer, we definitely need a voltage source to measure
Yes,
the
yes,
change in resistance.
definitely. You have to check now what is the resistance after giving this pressure or the
Change in
force.
the yes.
Yes.
Yeah. Okay, thank you.
Okay.
Ma'am, I have a doubt, ma'am. Ma'am, how do accumulation of charges affect conductivity, ma'am?
Piezoelectric sensor accumulate the charge in the response to mechanical force. Actually, here what is happening, when we are giving the force as the input of this piezoelectric sensor, there in the change of the electric charges, or they're forming some electric charge, then we are getting we are measuring this electric, how much electric charge is generated or how much electric charge changes when we are getting the input. We are getting the force as an input, and when there is no input, then we are how to measure this electric charge. So in the form of voltage we are measuring this electric charge for the piezoelectric sensor.
Yes, ma'am. Thank you, ma'am.
Okay, so we are moving towards the question number 5. So micromachining is the technique to procedure or fabricate MEMS device at micrometer scale. Below diagram show a cross-sectional view of VOC sensor fabricated. Which type of micromachining is it? So here you can see a device. So there is a micromachining or the VOC sensor. So can anyone tell what type of micromachining is used here? First option is the bulk. Second option is the surface micromachining. Third option is the A and B both. And fourth option is the none of the above. So please unmute yourself and try to give the answer. Can anyone tell me what is the surface micromachining and what is bulk micromachining? Then you can easily got the answer. What is happening for bulk micromachining, what is happening for surface micromachining, and here what is happening? Preetham?
Yes, I think surface micromachining, we have to remove only the surface, some part of the bulk wafer area. And in the bulk micromachining, we removing the most of the part of the wafer or a structure, and we need only the small area as our sensing device.
Bulk means inside the device we have to go, no? Means if we want to etch some devices, like there is a silicon structure, if you want to etch it and we want to make a diaphragm, then what is happening here?
So in that we are removing, suppose our wafer is a 50 or 100 micrometer thickness. So we have to remove most of the part, like 80 microns we have to remove, and only 220 microns of size we need as our device. That is, I think, bulk micromachining. We are removing the bulk part of the wafer or substrate. In the surface, we are just removing the little 20% or 10% of the surface area to structure our device on the surface of the wafer.
Okay, and not only we want to remove, we have to, and sometime we have to grow some pattern now on it, the surface.
Yeah,
yes,
that
it is
the
also
same
the part
thing
of the surface micromachining.
In surface, I think we have to interest on the surface area of the wafer, and in
yes.
right what I am saying, and
the
in
bulk,
the bulk
area
we
of
have to use the bulk part of the
maximum part of
maximum
this.
area of the wafer. Okay.
So here in this case what is happening?
In this, I think this is a surface micromachining.
Why it is only surface micromachining, not bulk micromachining?
I think it's a device, the sensing is the upper side, surface side of the.
Okay, in any of the device, it is sensing the upper side. Now, where the sensing layer is happen, in that part, it is for used for the sensing part. Okay, but also below of this device, below portion, there is also something now.
So this white area is a transparent or something is there? It's the cavity.
Yes, it
is.
This
Is a cavity, right?
It is like
diaphragm
cavity
kind of thing.
Yes, it is cavity type of things.
So I think this is a bulk, because we are removing a bulk of this.
Now the question is coming that why only the bulk? In the upper side also you can see now, after black portion there is a green, then after the green portion also there is a pattern, and after the pattern there is also some pink type of portion now. And in the below portion there is the cavity, so how it can be only surface or how it can be only bulk?
So maybe both, I think.
Yes. Anyone else? Anyone else? Sagar V. Please unmute yourself and try to give the answer.
Ma'am, that cavity is etched due to bulk micromachining, ma'am.
Okay.
And on that top, the layer between those two things is due to surface micromachining.
So the right option is?
Both A and B.
Okay, good. Anyone else? Here, Venkataraman.
So ma'am, in this device, suppose we not create this kind of diaphragm, there is no way cavity is there, then it's only the surface.
Yes, if there is no need of the like cavity type things, only we are working on the surface, then it is called surface micromachining. Then there is no need of the bulk micromachining, na?
So in any structure where we using both part for the structure, like the bulk area of the device and
also the surface area.
surface area
Hmm.
also for the sensing purpose,
Yes.
then
Then
both will be there.
both is needed in that case, no? Also we are
Okay.
working on the surface, some layer is growing or some etching is done or some
Yeah,
small portion
deposition
is
is there. Absolutely.
yes.
Okay.
And also in the below side we are etching most of the portion of this device, sorry, on of the device or wafer. Then in that case also the bulk micro machining is needed.
Okay.
Hitesh,
Ma'am.
what is the right answer?
Ma'am, I think A and B both are correct, ma'am.
Okay,
Option C.
can you please explain?
Have it gets due to bulk machining, ma'am. Oh,
Your voice is not clear. Ankur,
I think
Bharadwaj.
I think C answer is the correct answer
Okay. Can you please explain why option C?
because the device can be placed by both option by removing the top surface, inserting the device into cavity. Like this is it is showing into the figure.
Okay. And also why it is surface micro machining is happening here?
Because I think the top layer is matching with the side surface.
Okay.
That, that is why I think this is the correct.
Good.
In both methods,
So I think all of you get the concept of the bulk micro machining and the surface micro machining, and why here the option C is correct, and both bulk, yes, both bulk micro machining and surface micro machining is needed here. So we are moving towards our next question. So the question number 6 is, the class number of clean room denotes what among the following option? The pressure inside the clean room, the number of people permitted inside the room at a given time, the lifetime in year for faithful operation of the facility, and the number of the particles per cubic feet allowed inside the facility. So please unmute yourself and try to give the answer. Preetham, okay. Anyone else? Please unmute yourself and try to give the answer.
I think D answer is the correct answer.
Option?
Option B.
Option B. Can you please explain?
The number of particles per cubic feet allowed inside the facility. So,
Okay. So option B or option D is the right answer. Ankur?
yeah, I think the number of people permitted inside. I think D is the correct answer.
Which one? The number of people or number of particles?
Number of particles.
Okay. Anyone else? Bakwa Vani? Sagar V? Please unmute yourself and try to give the answer. Vishnu?
Ma'am, if class number increases, that denotes less purity, ma'am. So option D.
Okay. The number of particles per cubic feet allowed inside the facility. A.R. Venkataraman?
Yes, ma'am. The number of particle per cubic feet allows inside the facility because you increasing the number of peoples due to that it will affect that. So the answer is the number of particle per cubic feet allowed inside the facility. Answer D.
Okay. Okay, so the right option is the number of particles per cubic feet allowed inside the facility. So next we are moving towards our next question. Question number 7. A double-side polished N-type 1003-inch silicon wafer is to be cleaned in level 1 wet bench. Identify the step that does not apply to new wafer cleaning protocol. First option is perform Piranoha cleaning. Second option is the dip wafer into TIMA. And what is the full form of this TIMA? Tetramethyl ammonium hydroxide at 80 degrees centigrade. And the third option is the cleaning it with the DI water, deionized water. And the third option is purging with N2 gas. So what is the right answer? Please unmute yourself and try to give the answer. C. Identify the step that does not apply to new wafer cleaning protocol. So below this process, Piranoha cleaning, deep wafer into TIMA, and also cleaning with the DI water and purging the N2. Among these, which process is not done in the time of wafer cleaning? Can anyone say what is Piranoha? And
Pirana, I think, is a combination of two chemicals, na H2SO4 plus H2O2.
Yes, yes.
In the ratio of 3:1, I think 3 is H2SO4 and 1 is H2O2.
Yes, good. And by this process, what we have done?
Large particle impurities or organic impurities, I guess.
It's meant this process is a cleaning process and it's remove some particles from the wafer, right?
Yes, yes.
And what is TIMA? Why we dip wafer into the TIMA?
TIMA, I don't have idea.
Okay. Anyone else? A.R. Venkataraman? Just say what is a TIMA process. Means for which process we have to use this process. It is a cleaning process or not? My question is it. Can anyone tell why, if for the cleaning process DI water is used or not?
Yes, DI water is used for the wet cleaning.
Okay. For wet cleaning, we are using DI water. For also normal cases now, when after the Piranoha cleaning or something else, we
have
also
to dip
wash
the
the
wafer in the DI.
wafer with the DI water
Yes,
to remove the unwanted particles or unwanted chemicals from the wafer,
yes.
right? And purging with N2 gas, it is required for the cleaning process or not?
The gas we use for drying the wafer,
Yes.
that is, I think, for removing the DI water particles.
After
also.
removing the particle or chemical portion and from the wafer, we with the DI water, then we have to dry the wafer. So we purging the N2 gas to dry the wafer. So let's see. The first option, Piranoha cleaning process, then cleaning with DI water, and also purging with N2 gas. These all three processes are related to cleaning process. So only one option is here, na? The TIMA process. Actually, this is the etching process. When we have to go for the etching of the silicon, then we use it. And some chemical is also here. And then we have to dip the wafer into the into this solution, then it etch. Anisotropically, it etch the wafer, and also bulk micromachining is here. So what is the right answer here, which is not the part of the wafer cleaning protocol?
TEMA.
Option?
TEMA B.
TEMA, because it is a etching process. When we dip the wafer into the TEMA, TEMA means there is some solution, there is a combination of some chemicals, then it etch the wafer.
So it's a silicone etchant.
Yes.
Okay.
So we are moving towards the question number 8. During the lithography process after hard bake, the photoresist does not strip well using acid.
Hello, ma'am. Yeah, question number 7, right answer क्या?
Option 2, dip wafer into the TEMA, because first option, second option and third option is these three are related to the wafer cleaning process. So which is not for the wafer cleaning process? The option number 2, dip wafer into the TEMA. When we dip the wafer into the TEMA, there is a chemical, some combination of the chemicals, it etch the silicon. So it is a etching process. It is not related to the wafer cleaning process. Are you getting? Shankar? Bakbawani Shankar.
Yes, ma'am.
Okay. So this is our next question. During the lithography process after hard bake, the photoresist does not strip well using acetone and IPA. Which system can aid in stripping the resist? So this question we have directly taken from the lecture video, that which system is used to remove the photoresist which is not stripped well using the acetone or IPA. So which stripping process is used here? Which system is used here? Shaker, incubator, sonicator, or the strip plate, or the stirrer with hot plate? Please unmute yourself and try to give the answer. Preetham?
Not sure, but it's a strip plate. I think.
Vishnu? This question is directly taken from the video lecture. After the hard bake, the photoresist does not strip well using the acetone and IPA. Which system can aid in stripping the resist? Ankur? So if we put the device into this below among this system, then easily this photoresist is stripping, or it is removed, which is not removed by the acetone or IPA after the hard bake. There is a system. Vishnu? Ankur? At least you can try now. Please unmute yourself and try to give the answer. A.R. Venkataraman. What is the right answer? Electrical engineering. Option B, sonicator. Okay, good. Vishnu? A.R. Venkataraman. So the right option is the sonicator. Yes, A.R. Venkataraman.
I say it as triplet, but you say it as sonicator.
Yes, yes. Not a strip plate, it is sonicator. Here we have to use the sonicator to it can aid it is the photoresist, which is not removed by the acetone or the IPA.
Sonicator is the same device that we use during the cleaning process also for
Yes,
the
yes,
DI
yes.
agitation.
DI water, like DI water or IPA, when we are using it na for cleaning purpose. This
So
is
when
this is
the we remove during the removing PR, so we have to just put in the IP or acetone, then and put on the sonicator to
Yes, if
remove
we
the.
put on the sonicator, then it can easily remove the photoresist,
Okay.
because some portion of the photoresist is remaining if we go for the hard bake process. Then
Okay.
if we put the device into the acetone or the IPA, and you put the device into this sonicator, then easily it is removed.
Okay.
Okay. So we are moving towards our next question, question number 9. Buffer HF is used as a etchant to etch out a silicon dioxide layer known as BOE, buffer oxide etchant. Which kind of etching is this? Isotropic and dry etching, isotropic and wet etching, anisotropic and dry etching, and anisotropic and wet etching. So please unmute yourself and try to give the answer. Okay, Preetham, option B. Anyone else? Vishnu, Arya, sorry, Aisha. Vishnu, Bakwa, Vani, Sankar. What is the right answer?
No, ma'am, no idea.
Can anyone tell what is happening for isotropic or what is happening for anisotropic, and what is the difference between dry and wet etching? Preetham, you can unmute yourself and you can tell now what is the difference between the dry etching, and what is the difference between this dry and wet etching, and what is isotropic and anisotropic etching?
Ma'am, wet etching means
Yeah.
dipping that into that solution, ma'am.
Okay.
Dry etching means using gas to etch.
And for dry?
Ma'am, using gas to etch.
Gas or plasma type things, no?
Yes, ma'am.
Okay. And what is isotropic and anisotropic? When it is called isotropic and when it is called anisotropic?
It's related to direction. I think anisotropic means is particularly in one direction it's etching,
Yes,
and in
yes.
isotropic it's etching throughout all side of the.
Yes. So what is happening for the BOE? When BOE is applied for the etching of silicon dioxide, what is happening in that time?
In BHF,
Buffer oxide etchant, when it is applied, then what happened?
so BHF is a chemical. So we are putting silicon oxide to etch like during the native oxide created during the cleaning process also. So we are
Yes.
putting this wafer to remove the silicon oxide in the BHF. So it's a wet and it's a isotropic kind of etching process.
Yes,
So
because
till that the I think that silicon oxide is removed, it's showing some hydrophilic or something their term used, not just showing ki is repellent to water or showing the silicon is coming below the silicon oxide.
anyone
So
else?
silicon oxide is a hydrophilic, I think.
it's attract water. Now it means when there is a water part. So that's why now we are using the purging of N2 to dry this wafer. It is a hydrophilic or there is some difference between hydrophilic or hydrophobic. We have to see because if there is a drop of water, so we have to remove it because it attached to this wafer and there is a spot.
Yes.
That's why we purging the N2 gas to removing this water drop from the wafer.
Okay.
Anyone else? Shankar?
Option C, ma'am.
Option C. Why? Option C, anisotropic and dry aging. Can you please explain why? At least try, na? Please try to explain. Can you tell me what is dry aging? See here BOE is a solution. So when we put any device or any wafer into a solution or then this is called wet etching. For etching purpose we are using, that's why it is called wet etching. And also here when we are use the BOE, it etch in all directions. That's why it is called isotropic. If it is anisotropic, then only in a particular direction it etch out. But when we are using the BOE for etching the silicon dioxide, it is a solution, so it is called wet etching, the wet etching process, and also in all direction it is etched out the silicon dioxide. That's why it is called isotropic. So the right option is option B, isotropic and wet etching. Right? It is clear to all? Sankar?
Yes, ma'am. Yes, ma'am.
Okay. So we are moving towards the question number 10. So an oxide layer is grown on a new single side polished silicon wafer by dry oxidation. The oxidized wafer is coated with negative photoresist. For post-exposure, the wafer is subject to hard bake followed by the HF dip. The mask place is as shown in figure. Identify the pattern formed as the end of the HF dip. Considered green layer is oxide layer and orange layer is photoresist. So let's see. Here this is the mask design, black and white portion. This is the mask design which is negative photoresist. Mask design, and also we are using the negative photoresist. So can anyone say what is the difference between the negative photoresist and the positive photoresist? Please try to explain.
In positive photoresist, I think the exposed area is dissolved and removed from the after the litho process, and in the negative oppositely it's behave. Like the exposed area is remain there and the rest part is dissolved in the developer solution.
Okay.
And the dark part is hardened or remain there.
So here they are using the negative photoresist and this is the mask pattern. So then what is what they are done? Then the wafer is subject to hard bake followed by the HF dip. So what is the pattern is coming out after the HF dip? They are asking for it. The mask plate is shown in the figure. Identify the pattern formed at the end of the HF dip.
So answer I think will be first one. So the dark area is not exposed.
Why it is negative photoresist?
No,
Na?
sorry. This is a D, I think.
Okay. And why option D?
Because the dark area is not exposed. Dark area is not exposed. So it will be dissolved and the exposed area will be hardened.
Okay, so why not C? My question is it. Why option D?
Why not C? Because we have not removed yet the PR.
Yes. Anyone else? What is the right answer and why? Vishnu, please unmute yourself and try to give the answer. Vishnu, at least you can try now. Whatever is the answer, this is not the main things. At least you can try. Then I will explain why it is happening and what difficulties you are facing. Here Venkataraman, please unmute yourself and try to give the answer. Bakwa Bhani Sankar, what is the right answer? Vishnu, at least try. What is the right answer? Vishnu? Here Venkataraman.
No idea, ma'am.
Okay. At least you can try now. What is the figure coming out after this HFD and what is the process is going on? Why option as the Preetham said that the option D is the right answer. Why option D is the right answer? At least you can try now. If you have any doubt, then you can ask me. At least try. What is happening here? There is a wafer, silicon wafer, and after the silicon wafer there is a silicon dioxide layer. Then there is a PR layer, the photoresist layer. Then here the negative photoresist is here. Then what is happening for the negative photoresist?
Ma'am, the pattern changes, ma'am.
Okay, what type of pattern is transforming for the negative photoresist? If we exposed, then what type of pattern is transforming from this mask to the photoresist? Like here the white portion is the transparent layer, or the dark portion and the dark portion is the covered area. Okay, so can anyone tell what is happening for the positive photoresist and for what is happening for the negative photoresist? Vishnu, try.
Ma'am, for positive photoresist, the same pattern will be there, ma'am. No changes, ma'am.
For positive photoresist, yes, it means when light goes into this the exposed portion, then this exposed portion becomes soluble. When it deep into the solution, then the exposed portion is etched out or going out. Okay, so remaining area is which is coated with this black portion. So what is the black portion? That will this photoresist portion will remain. But what is going to happen for the negative photoresist then? Vishnu?
Ma'am, the covered layer will be transparent layer, ma'am.
Yes, it is not transparent. The covered area will be more soluble. It is opposite of the positive photoresist. When it is covered, for positive photoresist, when it is covered, then it will remain, and the other portion will etch out, or the other portion of the photoresist will gone. But for the negative photoresist which is covered, it is weaker, and the and the exposed area become more harder. So the covered area will etch out. Here we are using the negative photoresist. So what is happening for the negative photoresist? The cover area become soluble, and the exposed area is become harder. So like the bright portion, it is exposed. So for negative photoresist, this portion will remain. So for option C and D, see the white portion, this silicon dioxide layer is here, na Vishnu?
Yes, ma'am.
Yes. So options.
Option D, ma'am.
Okay. Option C and D, there the silicon dioxide layer is present for white portion, and the portion which is not which is covered for negative photoresist, this is become soluble. So this portion is etch out. Etch out means when we are deep into the wafer, into the solution, then we develop this device. Then in that time the PR is removed, which is for the UV exposed. Then when we dip into the HF solution, the silicon dioxide also etch out. That's why the here the silicon dioxide is etched. Also the third portion it is the uncovered area. It is the exposed portion. So here also the silicon dioxide is present. So now you understand?
Yes, ma'am.
Yes, but after the HF dip, there is no process for the the remaining PR removal. That's why the PR is here. Option D is the right option. Now all of you understand why option D is the right answer? Bakwahani Sankar, if any doubt, please tell.
No, ma'am. No, ma'am.
Clear?
Yes, ma'am. Ma'am, question number 1 and question number 2, please explain once, because I am late, join late.
Okay. So question number 1 is exhale breath analysis for diabetes diagnosis is a liquid phase VOC detection, that is minimally invasive procedure, solid phase VOC detection, that is invasive procedure, and the gas phase VOC detection, that is minimally invasive procedure. And the fourth option is the gas phase VOC detection, that is non-invasive procedure. So what is the right answer? Exhale breath analysis for diabetes diagnosis is a. So which process is used here? Shankar?
No, ma'am, no idea.
At first see what is happening for exhale breath. There is some gas type or liquid type. When you exhale the breath, what is happening? Gas or liquid is present in your exhale breath? It is gas, no?
Yes.
Okay. So at first tell me what is invasive process, what is non-invasive process, and what is minimally invasive. Do you have any idea?
No, ma'am.
Okay. See, for invasive process, we have to put the device into our body. And for non-invasive process, we are detecting the gases or some liquid. It is outside of the body. Then we detect the molecules, and it means all the processes outside of the body. It is called non-invasive. And if we put the device into the body, then it is called invasive process. But what is happening for the minimally invasive process, like a glucometer? When we put a drop of blood onto this device, then it detects the glucose level. It means it is not purely invasive process. The device is not going into our body, or we are not also we are not taking the data from, we are not detecting it outside of the body, right? We have put a drop and then it is detecting the glucose, the level of glucose. So this is called the minimally invasive. Now try to solve the answer question. Sorry.
Yes, ma'am.
What is happening? It is, at first, the first clue is that it is what is present in the exhale breath, it is in gas form. And then what is non-invasive and what is invasive and what is minimally. Now it is clear to you? Now
Yes, ma'am.
tell me the
Yes,
right
ma'am.
answer.
The right answer is the option C.
Like exhale breath, it is in gas, so gas phase VOC detection, right? Then what is happening in for the diabetes case?
Sorry, ma'am. Option A. Sorry. Option A.
Why option
But it is a madam liquid.
A? No, when we are breath out, it is present in the gaseous form, na? When we are inhaling the gas or or exhale the breath, na, it is in gaseous form. O2, what is in present, mostly what is present when we are exhale the breath? Carbon dioxide, maximum time the carbon dioxide, maximum percentage of carbon dioxide is present, and some other gases also present in our exhale breath. So here from the exhale breath they are detecting the diabetes, right? So it is in gaseous form. The first clue is it is in exhale breath, it is in gaseous form. The second clue, it is exhale breath, it is coming, it is detecting outside of the body. So what is the right answer?
Option D, ma'am.
Yes, option D. Because in exhale breath, it is all the all the molecules or gases is present in the gaseous phase. That's why the and what is the full form of the VOC? Volatile organic compound. So all in exhale breath, what is the volatile organic compound is present? It is in gaseous form, and also this VOC is detecting outside of the body. That's why it is called non-invasive procedure, right?
Yes, ma'am.
So it is clear?
Yes, ma'am.
Okay. So the next question is, which among the following is minimally invasive diagnostic procedure? Heart transplantation surgery, neurosurgery, disease detection using breath analysis, and glucometer based disease detection. So what is the right answer?
It is the ma'am option D, ma'am.
Option?
Option D.
Why?
Because
At first tell
it
me
is
what is
madam.
the minimally invasive diagnostic, because already I have told you what is minimally invasive, what is invasive, and what is non-invasive. So what is happening for the glucometer based disease detection? Inside, outside, or we take only a drop of blood?
Inside, ma'am. Glucometer is the inside, ma'am.
Sorry?
Glucometer is ma'am based in detection in inside body inside, ma'am.
No. For the detection of the glucose, we put a drop of blood on the glucometer, then it detects. It is not inside the body, or it is not properly outside. Nah? We put a drop of blood, then it detects. So it is called minimally. Right?
Yes, ma'am.
Okay. So this is our next question, question number 11. So the question is, in this deposition, so there is a mainly two type of deposition process is discussed in the lecture, that's CVD and PVD, the most popular deposition technique. So here, what is the full form of this PVD technique?
Physical vapor deposition.
Okay. Any other answer? Okay. Anyone else? Shankar? What is the right answer? At least you can try, na? What is the right answer? Pakmavani Shankar? Okay, the right answer is the physical vapor deposition. Preetham, can you explain what is happening in the for the physical vapor deposition and what is happening for the chemical vapor deposition? What is the main difference here?
Yeah, the main difference between CVD and PVD is in PVD, we are just depositing the material directly on the wherever we want, and in CVD there is a chemical reaction is there with
Directly
the
means
material.
how?
Like in thermal, in this purity technique, we have some substrate where we want to deposit like metal or something. So we have two things: one is a target, one is a substrate, and in a chamber with the high vacuum, we just evaporating that target material, and directly we deposit that metal on the substrate. That is the PVD process. There is no chemical reaction is there with the substrate. But in CVD process, we use the material that we want to deposit, but there is a reaction with the substrate material. I think that I understood.
Yes. So you're a PhD student or a MTech student?
No, I am just a MS student.
You are doing
MSR,
MS. Okay. And where are you from?
IIT Delhi.
Okay, okay, good. So are you working on the fabrication process or something else?
No, my work is related to the reliability with the semiconductor devices. Reliability testing, but I have taken this course just for understanding the fabrication process.
Okay, okay. So in which year you were doing?
No, I have just submitted my thesis, but this course has left to understand. So I have option online, so I can attend from here. Actually, I want to do with this professor Hardik Pandya. He is from, I think, he graduated from IIT Delhi. I have listened about sir so many good works, so I have to just go through this course.
Okay, okay, good. So we are moving towards the next question. The question number 12. Evaluate whether the following statement is true or false. Accumulator is a mechanism that converts some type of energy into motion in order to do the work. True or false? So please unmute yourself and try to solve this question. Accumulator is a mechanism that converts some type of energy into motion in order to do work.
Yes, ma'am.
So what is the
It's
answer?
option A.
Okay. Anyone else? Okay. Bhagwani Shankar, what is the right answer?
Ma'am, option A.
Can you please explain why? At first tell me what is actuator. So what is happening for the actuator? At least try.
Ma'am, I am a student in a read, but I have no idea in this subject or machine.
At least try na. It is also discussed in the lecture. What is actuator, what is sensor, and what is happening for which type of input data there is given, and what type of output is we are getting. This is already explained in this lecture, na? Pritham, can you explain why yes or true?
Yes, in a sensor, we just sensing the one energy in form of electric, like in any like thermal sensing, we are using thermocouple or thermistor. But in actuator, we have one extra work that actuate any further reaction, like thermostatic plates that sensing temperature, but also they have to transfer this energy to stop turn on any other further device. So that
Yes.
is the kind of actuating
Can you give
reaction
me
is
one
there.
example of the actuator?
That I understood the thermostatic plate we use in the heater that sensing temperature, and when the set point of temperature is reached, that cut out the our heater. So that is actuating process with sensing.
Okay. It's mean it's convert some type of energy into a motion. It's do some
Yes.
work, and by
Yeah, bending of that is thermistor is that emotion.
yes. So it is converting some type of energy into motion in order to do some work. This is called actuator. So the right option is true. This is our next question. So most common actuator used in ROV, remotely and
Ma'am, all
also
of these.
this question, remotely operated vehicles, I think ROV full form is, and this question is directly taken from the lecture video. So most common actuator, here this is the example of some of the actuator, so which is used in the case of the remotely operated vehicles: motors, solenoids, or the hydraulics, or all of the above.
Ma'am, all of this, ma'am.
Okay. Anyone else?
Yes, ma'am. All of these.
Okay. Preetham?
According to me, I think only solenoid maybe.
No, actually, all of the above are used
Ma'am,
for.
But how
ma'am,
motor is a actuator? It means it's not sensing anything.
Yes.
ये जो मैम ROV is a remote operated vehicle, and all the things are used in a vehicle. So it is
Yes.
all of the above.
Yes, correct answer. And also, this question is directly taken from the lecture video, so you also can see there. The motor, solenoids, and also the hydraulic is used for in this ROV. And all of these are the example of the actuators, right?
Yes, ma'am.
So some common, we are moving towards the next question, question number 40. Some common MEMS actuator are piezoelectric, thermal, magnetic, or all of the above. This is the
All of this.
same type of question.
All
Anyone
of this.
else? Please try to explain. some common MEMS actuators. Bakwawani Shankar. Shankar.
Yes, ma'am. 2 minutes.
What is the right answer? Can anyone explain why and what is the right answer? Vishnu?
Ma'am, piezoelectric converts mechanical signal to electrical, ma'am.
Okay.
In terms of voltage.
And for thermal?
Heat into electricity.
Okay. Magnetic?
Ma'am, I'm not sure about that, ma'am.
Preetham? Out of power. Okay. But also the magnetic case also the MEMS actuators. So here also the answer is all of the above. So you are right. So we are moving towards the question number 15. This question is also directly taken from the lecture video. That MEMS made up of component between which micrometer in size? 1 to 100 micrometer in size, or 100 to 1000 micrometer in size, or 1000 to 10,000 micrometer in size, or none of the above.
Ma'am, option A, ma'am.
Option A.
Yes, ma'am. Option A, ma'am.
Why option A 1 to 100 or not 100 to 1000? Micrometer size, na? It is very, not 1 micrometer. MEMS device. MEMS made up of component between 100 to 1000 or 1 to 100. Because means MEMS device also, some device is in millimeter range. Micrometer also, and also is in millimeter range. So that's why it is for 100 to 1000 micrometer in size. And also it is discussed in the lecture video, and it is directly taken from there. So MEMS made up of component between 100, it is taken 100 to the 1000 micrometer in size. This is the question number 16. The component of MEMS are. So what is the full form of the MEMS? Can anyone tell? Shankar, Vishnu.
I'm option B, ma'am.
Okay, microelectronics, microsensor, microactuator, and microstructure. Anyone else? Vishnu? Sorry, Vishnu, I think Vishnu already told the answer. So, Shankar, what is the right answer?
No, ma'am. No idea.
Okay, see, the common components of the MEMS are microelectronics, microsensor, microactuator, and microstructure. At first, microelectronics is the main part. Then the microsensor, it sends the data and it's sending to the microelectronics. And microactuator get this data and it's do some work. So it is transfer some of the energy into the motion. That's on microstructure. What is microstructure? Some structure there is a some micrometer range of the structure. So the main component of the MEMS are microelectronics, microsensor, microactuator, and the microstructure. Now you get the answer, Shankar. Why option B is the correct answer? Hello? Bhagwa Vani Shankar? So next we are moving towards the question number 17. Which component of the MEMS is called brain that receive and process and makes the decision? First option is the microelectronics, second option is the microsensors, third option is the micro actuators, and fourth option is the microstructure. So what is the main part?
Option A, ma'am.
Microelectronics. Good. Bapavani Shankar, what is the right answer? At least try.
Option A, ma'am.
Okay, good. At least try. Maybe it is right, maybe it is wrong, but at least if you try, then also it is it will clear your doubt. So the main component of the MEMS, micro electromechanical system, which is called the brain that receive and process the data and it makes the decision. So this is called the microelectronics. This is the main part of the MEMS devices. Now coming to the question number 18. Which component of the MEM constantly gather data from environment and pass the data to the microelectronics for processing? First option is the microelectronics, second option is the microsensor, third option is the micro actuator, and the last option is the microstructure. So please try to solve the question. At least try. Vishnu? Which component of the MEMS?
Option B.
Okay, microsensor. Shankar?
Ma'am, option D, ma'am.
Option D is the microstructure.
Yes, ma'am.
C. Which component of the MEMS constantly gather data from environment and pass the data to the microelectronics process? It means it is taking input from the environment, then it is processed and it is converting this input signal into some output signals and it is giving the data to the microelectronics for the processing. It means if we are taking our bodies, then the hand is acting as is a sensor which is taking the data from the outside or the environment, then it is processed and the electrical signal is going to our brain, like that. What is happening for the sensor? It is converting some physical phenomena or the physical signal into some electrical, mechanical or optical signal. So in that cases, the microsensor, what is happening for the cases? For microsensor, it is taking the data from the environment, it is gathered the data and it is passed the data to microelectronics. It is the microelectronics is the brain. So the microsensor gather the data from the environment and pass the data to the microelectronics for the processing, right? So the right option is microsensor. Have you got it, Shankar?
Yes, ma'am.
Now what is the right answer? Yes, Vishnu?
And what's the difference between a piezoelectric sensor and a transducer, ma'am? How it works, ma'am?
Okay. Like what is happening for the piezoelectric sensor? When we are getting the when we put some input like force on the piezoelectric devices, then it's convert or it changes, it generates some electric charge, which we measure the electric charge in the form of the voltage. It is called the what is piezoelectric sensor. And what is the role of the transducer? It is converting the electrical signal to the observable or measurable signal. So when we are when we want to take the data, at first physical signal converting, what is the sensor? Physical signal converting into the some electrical or some optical or mechanical signal. Then this signal, after the converting of this data, this signal is also what we can't measure the electrical also directly, electrical signal we can't measure. So that's why we use the transducer that also transfer this electrical signal to some physical activity or physical signal. Now you get your answer.
Yes, ma'am. Ma'am,
It's
so
converting.
without the transducers, we can't detect the change, ma'am.
If we like some, there is some other also the processor or some devices is there na, then we can detect the electrical signal also. We have to measure the electrical signal by this some devices na. If you want to see the curve like the IV characteristics or the current voltage characteristic, then what we have to join some data, join some device with this sensor, then we can see the data na.
Yes, ma'am.
So this electrical signal, then you can see with the visualize, you can visualize with some of the device. We can directly, we can't directly see na. The main portion is the energy transform from electrical or something else is converting into some other energy or some other signal. This is called the transducer.
Yes, ma'am.
So coming to the question number 19. Which component of the MEMS acts as a trigger to activate the external device? So microelectronics, microsensor, microactuator and microstructure. So please try to give the answer.
Option C, ma'am.
Okay. Vishnu?
Ma'am?
Oh, sorry. Okay. Shankar? Shankar? At least try, na? Which component of the MEMS acts as trigger to activate the external devices? Option A is the microelectronics, which is the brain of the MEMS, and then microsensor, which gather the data from the environment, then it passed to the microelectronics, then the microactuator. What is actuator? It's convert some of the energy and it is convert into a motion, and it do some work to show the motion, right? So here what is happening? Acts the which component of the MEMS acts as a trigger to activate external device? So it triggered the micro actuator trigger to activate the external devices. So it do some work and it's convert the some energy into the motion. That's why the right answer is the micro actuators. So we are moving towards the question number 20. Which component of the MEMS are extremely small structure built onto a surface chip? Microelectronics, microsensor, microactuator or microstructure?
Option D, ma'am.
Okay. Can you explain why? It is a very easy question and your answer is in the question also. So please explain why microstructure?
Ma'am, on the surface, they are built on, they are made, ma'am. So,
Yes, because it is a small structure which is built onto the surface chip. That's why it is called microstructure, right?
yes, ma'am.
Next we are moving towards the question number 21, which is not a PVD technique. So what is the full form of the PVD?
Physical vapor deposition.
Yes. So which is not a PVD technique. ALD, atomic layer deposition, E-beam evaporation, thermal evaporation and this spotting.
I'm option A, ma'am. It's
Yes.
not a PVD.
Shankar? Bhagwani Shankar? What is the right answer? At least try now. What is the right answer? So the right answer is the AD. Because in e-beam evaporation, also the thermal evaporation and sputtering, there the some there is the PVD technique is here, and only the ALD process, the atomic layer deposition, is not the PVD technique. Next question, question number 22. Evaluate whether the following statement is true or false. We can deposit any material which has a lower melting point compared to the source material. It is true or false? Vishnu?
Ma'am, it's correct, ma'am.
Yes. Why?
Ma'am, because if the melting point of the source is less than the material, means first the source will get melted, no ma'am. So
Yes, the source will melt. So the evaporation, what we want, the evaporation will not get properly. So other material or the source material will deposit onto the surface of the wafer, right?
yes, ma'am.
Okay. So this is the next question, question number 23. Transfer of a pattern into a material after deposition in order to prepare for etching is called etching, patterning, PVD or CVD. So which is the right, what is the right answer? Transfer of a pattern into a material after deposition in order to prepare for etching. It is preparing for etching.
Patterning, ma'am.
Yes, it is a pattern. It is called patterning. So transfer of pattern into a material. So some pattern is transforming, patterning here, and it is transforming from the mask to the some deposited layer. So it is called patterning. This is the next question. Question number 24. Dipping substrate into chemical solution that selectively remove the material. This process is called dry etching, wet etching, or both A and B, or none of the above. So what is the right answer?
Wet etching.
Yes. Why wet etching?
Because the substance gets wet, no ma'am.
Because here the chemical solution is used. The substrate is deep into the chemical solution. That's why it is called wet etching. And what is happening for the dry etching?
Passing gas or plasma.
Yes. Right, good. So passing gas or plasma, then it etch out the some of the layer. This is called dry etching. This is the question number 25. Material sputtered or dissolved from substrate with plasma or gas variations. This process is called?
Option A.
Yes, dry etching. Right? Shankar? What
Yes,
is the
ma'am.
right answer?
Dry. Option A, ma'am. Dry etching.
Okay, good. So question number 26. What is the value of the angle? Here you can see now there is a mask design and the silicon layer, and in between this mask design and the silicon layer there is an angle. So what is the value of the angle? And the angle in between the 1 plane and the 1 plane. So what is the value of the angle? Can anyone guess? And it is also discussed in the lecture video.
54.7.
Okay. Shankar, what is the right answer?
No idea.
Okay. So the right answer is the 54.7 degree. So the angle when it is, and here what is happening? Vishnu, can you tell what is happening here? What type of etching process it is?
Wet etching, ma'am.
Okay. Anisotropic or isotropic? See, what is happening for isotropic aging? It is aged out all of the direction. And what is anisotropic? It is particularly in on direction it is aged out. So here in particular direction it is aging. Na? So what is the process here?
Anisotropic, ma'am.
Yes, right. This is called anisotropic weight aging. So in the in the plane between in the angle between the plane 110 and 111 is 54.7 degree. So option B is the right answer. Next we are moving towards the question number 27. What is lithography? The first option is process used to transfer a pattern to a layer on the chip, or process used to develop an oxidation layer on the chip. And the third option is the process used to develop a metal layer on the chip, or the fourth option is the process used to produce the chip. So what is the right answer? What is lithography? Vishnu? At least try, na? What is the right answer?
Ma'am, option A, ma'am.
Yes. Why not option B? What is happening for the option B? Develop an oxidation layer. It means it's growing silicon dioxide on the device or on the wafer. So it is called oxidation. It is not lithography. So what is happening for the lithography? We transfer a pattern from the mask to the a underlying layer. So process used to transfer a pattern to a layer on the chip is called lithography process. So right option is the option A. So we are moving towards the question number 28. There are two basic type of photoresist. A positive photoresist, negative photoresist. So which of the following statement is true for positive photoresist? First option is with positive photoresist, the exposed region are dissolved during the develop. And the second option is which positive resist, the exposed region are hardened during the develop. And the third option is all of the above. And the fourth option is the none of the above. So which of the option is the right answer?
Option A, ma'am.
Yes. So with positive photoresist, the exposed region are dissolved during the development. Next we are moving toward the question number 29. There are two basic type of photoresist, positive and negative. Which of the following statement is true for negative photoresist? With negative photoresist, the exposed region are dissolved during the develop. With negative photoresist, the exposed region are hardened during the develop. Third option is all of the above and the fourth option is none of the above. So what is the right answer? Vishnu?
Ma'am, option B, ma'am.
Okay. Shankar, what is the right answer here? At least try. What is the right answer? What is happening for the negative photoresist? So for the negative photoresist, the exposed region are hardened during the develop. Sorry, yes, with the negative photoresist, the exposed region are dissolved. No, for the negative photoresist, the covered area is dissolved into the development and the exposed region become more harder. So we are moving toward the question number 30. Positive photoresist are used to more than negative photoresist because negative photoresist are more sensitive to light, but their photolithographic resolution is not as high as that of positive photoresist. The second option is the positive photoresist are more sensitive to light, but their photolithographic resolution is not as high as that of negative photoresist. And the third option is the negative photoresist are less sensitive to light, and the fourth option is positive photoresist are less sensitive to light. So what is the right answer here, Vishnu? Try now. What is the right answer? Why positive photoregists are used more than negative photoregists? Vishnu? So the right
Ma'am,
yes.
resolution is higher, ma'am.
Which option is the right answer? Option A or B? Or C or
B,
D?
ma'am.
Option A, right? Yes, the right option is the option A. Negative photoregists are more sensitive to light, but their photolithographic resolution is not as high as that of positive photoregist, right?
Yes, ma'am.
So the question number 31. Dash is one of the primer which is coated to improve the adhesion of photoresist on the surface of the substrate. TIMA, HMDS, the hexamethyl disalinase, Piranha and all of the above. So what is the right answer? Vishnu? TIMA is a etching process. Anisotropic wet etching process. Piranha is a
B, ma'am.
cleaning process.
B, ma'am.
Yes, HMDS, hexamethyl disalinase, is used to improve the adhesion of the photoresist on the surface of the substrate. Question number 32. Which is a wafer cleaning process? So here you can easily, it is an easy question, so here you can say what is the wafer cleaning process. Previously also we have discussed.
Ma'am, all of them, ma'am.
No. TIMA is a etching process.
Sorry, ma'am. Sorry.
We etch silicon, it is wet etching and anisotropic. Piranha is a
Ma'am, option
wafer
B,
cleaning
ma'am.
process and deep wafer into HF to remove the native oxide layer. If we put the device into outside on the open environment, there is a native oxide generated, na? So we remove this native oxide by using this dipping the wafer into the HF solution. So only the Piranha process is the cleaning process, wafer cleaning process, right?
Yes, ma'am.
Okay. Then question number 33. Which gas is used for dry the wafer? Argon, N2, oxide and all of the above.
B, ma'am.
Yes, right. So question number 34. Which type of etching process is used in the figure? Wet isotropic. First figure is wet isotropic, wet and isotropic, and the second figure is wet anisotropic, or the first figure for wet anisotropic and the second figure for wet isotropic, and the third option is the dry anisotropic and dry isotropic, and the fourth option is the dry isotropic and dry anisotropic. So what is the right option?
Option B.
Yes, option B is the right answer. So today we end here. We will meet again next Tuesday 7 to 9. Good.
Ma'am.
Yes.
Ma'am, will the NPTEL questions will also be of same difficulty, ma'am?
Sorry, I did not get you.
Ma'am, the NPTEL final exam, no, ma'am.
Okay.
Will it be of the same difficulty, ma'am?
Same difficulty means?
Same kind of
Yes,
problems.
what is in your assignment? Na? That type of question will come. Not the same,
Yes,
but
ma'am.
that type.
Yes, ma'am. Thank you, ma'am.
Okay, okay. Thank you.